What if every black hole, every collapsed sun across the cosmos wasn't alone? What if they were threads in one vast, invisible web, pulsing beneath spacetime itself? And one day that network wakes up, fade to black static hum of gravitational echoes. It began not with darkness, but with an equation, a line of symbols that bent the universe itself. In the winter of 1915, as Europe tore itself apart, a man sat alone at his desk in Berlin, reshaping the laws of reality. Albert Einstein had discovered that gravity was not a force, but a curvature, the bending of space-time by mass and energy. It was a revelation that made the cosmos fluid, alive, and strange. Far away in the mud and blood of the First World War. Another man, Karl Schwarzschild, read Einstein's equations from the front. Mortally ill, surrounded by chaos, he wrote back to Einstein with a solution so perfect, so terrifying, it defied comprehension. It described a point of infinite density, a singularity, a place where space-time itself collapsed inward and nothing could escape. Einstein refused to believe it. He called it unphysical, a mathematical ghost that could never exist in nature. He didn't yet know that the universe would one day prove him wrong. For decades, the idea slept. Scientists treated it as a curiosity, a flaw in the elegant machinery of relativity. Space was supposed to be continuous, not torn. Time was supposed to flow, not stop. But the equations, silent, patient, waited. Then came the radio telescopes. In the 1960s, astronomers detected something impossible, distant points in the sky blazing with the light of 1 trillion suns. They called them quasars, quasi-stellar objects, but they were no ordinary stars. They were engines burning at the hearts of galaxies, powered by something invisible, something that consumed light, yet released more energy than entire galaxies could produce. The term black hole hadn't yet been born, but its presence was undeniable. It was as if the universe itself had opened hidden mouths in its fabric, devouring matter, yet singing with radiation. Soon the evidence grew. Stars seen orbiting empty space, jets of plasma shooting from galactic cores, an invisible power sculpting galaxies into spirals and clusters. Astronomers began to realize that these monsters were not rare. They were everywhere. Every major galaxy, it seemed, hid a black hole at its heart. In 1971, the star Cygnus X, one flickered with strange X-ray bursts. Two scientists, Tom Bolton and Louise Webster, found that it was orbiting something dark, massive, and silent. Something that could not be seen, only felt. This was the first true black hole ever confirmed, a point of no return, an edge to reality itself. And yet, the more scientists studied them, the more they realized how precise, how organized, how musical these voids could be. When two black holes spiral together, they do not crash, they sing. Their dance ripples space-time itself, sending waves through the fabric of the cosmos. Each collision releases more energy in an instant than all the stars in the visible universe combined. And still, what emerges afterward is silence, a deeper, darker silence than before. Black holes became the great paradox of existence, objects that erase everything, yet reveal the deepest truths about space and time. They are destruction and creation intertwined, entropy and elegance folded together. To the human eye, they are invisible, but to the equations, they are music. Each one curves space-time like a note in an unseen composition. If the universe could be heard instead of seen, It would not shine, it would resonate. Every black hole would vibrate the geometry around it, a baseline in the symphony of gravity. And so a question began to emerge, quiet but persistent. If each black hole bends space-time, and space-time connects everything, then could they all, in some way, be vibrating together? Could every black hole, from the smallest remnant of a dead star to the supermassive giants at the hearts of galaxies, be linked through the invisible medium of space-time itself? Could the universe be not a scattered field of silent graves, but a web of resonant nodes, a cosmic orchestra bound by gravity's unseen strings? Scientists had no proof, only whispers, mathematical hints, faint symmetries, patterns too grand to measure. But the idea refused to fade. Every discovery, every image, every signal seemed to hum with the same suggestion, that black holes might not be isolated beasts in the dark, but instruments in a vast, coherent design. Einstein had once seen them as monsters. Now they looked more like architects, the sculptors of galaxies, the conductors of cosmic order. And as the first telescopes began to map their positions across the sky, thousands, then millions, then billions, an eerie harmony began to emerge. They were not scattered at random. They formed filaments, threads, and vast cosmic webs, tracing the shape of the universe itself. Perhaps, in ways still unknown, they were talking, not in light, not in matter, but in the silent language of curvature and time. For if every black hole bends the same fabric, then none of them are truly alone. Perhaps they were never singular, but plural, singing across the dark. For a century, the universe was silent. Stars burned, galaxies collided, and black holes devoured. But all of it happened in silence. Astronomy had always been an art of light, the visible, the radiant, the luminous echoes of distant suns. But light, for all its brilliance, could never tell the full story. It could never reveal what happens when reality itself begins to move. Then, in September 2015, silence broke. Two black holes, each 30 times the mass of the Sun, spiraled toward each other in a galaxy over 1 billion light-years away. For eons, their orbit had tightened, their gravitational dance winding closer, faster, hotter, until, in a final instant, they collided. Not with light, not with fire, but with a sound. It was not a sound any ear could hear, a frequency so deep it rippled through the fabric of space-time itself. When the LIGO Observatory in the deserts of Washington and Louisiana captured that ripple, the data looked like a faint heartbeat, a rise, a fall, then silence. A wave that began before life on Earth had even evolved and ended in a laboratory 100 years after. Einstein wrote the equations that made it possible. For the first time in history, humanity heard the universe move. What LIGO detected wasn't a signal made of particles or photons. It was reality itself, stretching, compressing, breathing. A trillionth of a change in distance. Barely enough to move an atom, yet powerful enough to shake the entire cosmos. Physicists Kip Thorne, Rainer Weiss, and Barry Barish, the architects of this century-long dream, realized what it meant. Every black hole collision is a voice. Every merger sends a pulse through the universe, a message written not in light, but in gravity. The discovery changed everything. Light travels through space, but gravitational waves are space, the motion of the cosmic fabric itself. They move unhindered, untouched by dust or distance, carrying the pure geometry of an event across eternity. In that moment, black holes were no longer silent devourers. They became communicators, transmitters, in a network woven through space-time. Each collision wasn't an isolated act of destruction. It was a signal spreading through the universe, rippling through the same field that all black holes share. The realization was as terrifying as it was beautiful. Because if every ripple moves through the same space-time fabric, then every black hole can, in principle, feel it. Not as thought or consciousness, but as resonance. The universe itself could be resonant, one vast instrument, trembling with the echoes of its own catastrophes. The data poured in. More collisions, more waves, each one distinct, yet all following the same pattern, spirals of gravity winding into perfect stillness. It was as if the cosmos were learning to speak a new language, and humans had just overheard its first word. Einstein had predicted these waves in 1916, and even he doubted they could ever be detected. They were too faint, too elusive. He called them so small, no human instrument could ever hope to measure them. And yet, a century later, laser light split and mirrored between two vacuum tunnels 4 kilometers long, proved him wrong. We had built an ear, capable of listening to the heartbeat of spacetime. Each detection told a story of immense violence and perfect order. Two black holes merge, their orbit quickens. Their energy radiates, not in light, but in curvature. As they fuse, space-time quivers, and a pulse spreads outward at the speed of causality itself. By the time it reaches Earth, it is so faint it can pass through the planet without slowing, yet still measurable by a single photon's whisper of interference. That pulse doesn't vanish. It travels forever, carrying with it a memory, a fingerprint of the collision encoded in space-time. And if every black hole produces such a pulse, then space-time is filled with them. Countless waves crossing, merging, layering, a cosmic ocean of motion. Some physicists began to see patterns. Gravitational waves, they noted, behave like information, pure, lossless, self-propagating data. They don't dissipate. They persist. They can interfere, combine, even amplify each other. What if, they wondered, the universe wasn't a static arena, but a living web of vibrations, a nervous system made of gravity itself? If black holes are the nodes of this web, then each one is both receiver and transmitter. Every time they collide, the entire network trembles from the heart of the Milky Way to the edge of the observable universe. The cosmos might be whispering to itself through waves of distortion and time. The analogy deepened. In the brain, neurons communicate through electrical pulses across a sea of connections, synapses, forming patterns that generate thought. In the cosmos, black holes may communicate through gravitational pulses across the geometry of space-time, waves forming patterns that generate structure. Filaments of galaxies connect like tendrils in a neural map. Black holes sit at the intersections, massive and silent until they move. And when they do, the entire web responds. No one knows if this analogy is more than poetic, but it lingers, the sense that what humanity is measuring is not random noise, but coordinated motion, a structure large enough to contain itself. For the first time, scientists began to speak of the gravitational wave background, a faint hum filling all of space-time. Billions of overlapping signals from collisions across cosmic history, an ocean of vibration, and deep beneath it, perhaps, the trace of an order we have yet to understand. When the signal of that first collision faded, one scientist described it not as a sound, but as an awakening. He said it felt as if the universe had opened an eye that had been closed since time began. The discovery shattered the illusion of stillness. Space itself is not static. It breathes. It contracts and expands. It rings like a drum struck by invisible hands. And those hands belong to black holes, the sculptors of space-time, hammering reality into rhythm. It is a revelation that changes perspective. Humans are not outside observers. They are ripples inside the same field, moving with the same invisible tide. Every heartbeat, every planet's orbit, every atom's vibration, all occur within a space-time that is alive with motion, trembling with the memory of ancient collisions. If black holes are the drummers of the cosmos, then their music is written in the curvature of existence itself. Each collision is a note, each wave a phrase, and together they compose a song that stretches across eternity. The question now is not whether the universe vibrates. It does. The question is whether those vibrations are random or coordinated, whether black holes, through gravity's hidden geometry, are exchanging more than energy, whether they are bound in a lattice of shared motion, a cosmic nervous system pulsing with gravitational thought. It is a terrifying, exquisite possibility that we do not simply live in the universe. We live inside something that feels itself move. In the late 1990s, a quiet revolution began, not in a telescope dome or a collider hall, but on paper. Equations, not stars, were about to reshape what space even meant. In 1997, a young Argentine physicist named Juan Maldacena published an idea so bold that it bridged the deepest divide in physics, the chasm between Einstein's curved space-time and the quantum world's invisible code. It was called the ADS-CFT correspondence, and it whispered a terrifying possibility that our universe, the space we move through, the time we live in, might not be fundamental at all. It might be a projection, a hologram cast from a deeper, invisible reality. According to Maldacena's equations, everything inside a volume of space, matter, energy, even black holes could be encoded on its boundary, like information on a cosmic screen. Reality itself could be a shadow, an image formed by data written at the edges of the universe. If that were true, black holes were no longer just celestial abysses. They were servers in a cosmic information field, perfect storage devices holding the data of everything they swallow. Stephen Hawking had long insisted that black holes destroy information, that anything crossing their horizon was lost forever. But if the holographic principle was right, then nothing is ever truly lost. Every particle, every atom, every heartbeat that falls into a black hole remains encoded, smeared across its surface in patterns smaller than the Planck length, written into the geometry of existence itself. The implications rippled through physics like a shockwave. If a black hole can store the information of what it consumes, and space-time itself emerges from information, then perhaps information, not matter, is the true substance of reality. And if that's true, black holes are not singularities at all. They are nodes, knots in the fabric of an informational cosmos. But how, scientists wondered, are these nodes connected? The answer came 16 years later. In 2013, two physicists, Leonard Susskind and Maldacena, again proposed a new idea. equals EPR. It sounds like code, and in a way, it is. Two initials hiding a cosmic secret. R stands for Einstein-Rosen bridges, wormholes, theoretical tunnels through space-time. EPR refers to Einstein-Podolsky-Rosen pairs, the famous paradox of quantum entanglement, where two particles remain connected across any distance. Susskind and Maldacena suggested something astonishing. These two were the same thing. Entanglement, they proposed, is geometry. When two particles become entangled, a microscopic bridge forms between them, a tunnel through space-time itself. Wormholes are not science fiction. They are the structure of connection at the heart of reality. If that's true, then black holes, the most entangled objects in the universe, are riddled with these hidden bridges. Each pair of entangled black holes is joined by a quantum thread. And since black holes can share entanglement across unimaginable distances, the entire universe might already be woven together by a network of invisible wormholes, a cosmic web beneath the void. The idea sounds impossible, but simulations have begun to reveal its fingerprints. Quantum models show that when two black holes are entangled, changes in one can instantly affect the other, not through space, not through time, but through the geometry of connection. They mirror each other's quantum states, as if part of the same organism, separated not by distance, but by perception. It means the universe could be far less like an empty expanse, and far more like a fabric, one that folds and flexes where information ties itself in knots. In this view, space-time is not a stage on which matter performs. It is the performance itself, the outcome of countless entangled interactions, each one defining the shape of what we call here and now. At the smallest scales, beneath all matter, beneath even energy, there is pattern, entanglement forming and unforming like threads of silk spun through nothingness. Each connection creates a tiny bit of space-time. Each disconnection unravels it. And where entanglement becomes so dense that even light cannot escape, a black hole is born, the densest knot in the web. From this perspective, black holes are not holes at all. They are the anchors of reality, the points where the cosmic code writes itself in the highest resolution. Without them, the universe might not even hold together. Some theorists describe it like this: imagine space-time as a vast, glowing tapestry. Each strand is a quantum connection, humming with the information it carries. At certain intersections, the strands tighten, twist, and collapse into themselves. Those intersections are black holes. Remove them, and the web loses its tension. Keep them, and the structure persists. Gravity, then, is not just curvature. It is entanglement at scale. The pull of a black hole isn't merely mass. It's the geometry of shared information, pulling everything toward connection at Princeton and Stanford. Physicists have begun modeling these ideas using quantum simulators, synthetic toy universes built from entangled particles. In some of them, space-time itself appears to emerge. A map of distances and curvature forms naturally from the pattern of entanglement, as if reality is a consequence of information trying to remain whole in these simulations. Tearing the web, cutting entanglement, collapses space-time. Restoring it brings the geometry back. It's as though the universe has no true voids, only disconnected regions of information waiting to be rewoven. The parallel is haunting. In the human brain, consciousness arises not from isolated neurons, but from the network, the endless exchange of signals. Perhaps the cosmos functions the same way. Each black hole, each entangled knot, a neuron in a galactic brain. Each gravitational wave, a signal flashing between them. And the universe, vast and silent, could be the echo of that network learning or remembering itself. The void is not empty. It hums with hidden symmetry. Every flicker of a collapsing star, every oscillation of a distant merger, every silent rotation of an unseen giant, all of it feeds into the same fabric, the same system of invisible threads binding all that is. The frontier of modern physics now lies here in this unseen geometry, not in the galaxies we can photograph, but in the relationships we cannot. Space may not be built from distance, but from connection. And the deeper we look into the black, the more it seems that what we call nothingness is alive with structure, whispering through the fields, encoded in the silence between stars. If black holes are the knots of this grand tapestry, then the universe itself may be the loom, weaving and unweaving reality in every passing moment. From the quantum to the cosmic, it's no longer clear where one black hole ends and another begins, or whether those boundaries even exist at all. Perhaps they share something deeper than gravity, a constant, unbroken conversation, carried by the same invisible strands that hold existence together. And if so, then all across the cosmos, in the emptiest stretches of night, connections may already be humming, unseen, unfelt, but real. Threads between monsters, whispers between singularities, the song of the void itself, played on strings of spacetime. Maybe the void isn't empty, it's whispering. In the beginning, there was silence, or so we thought. But in 2023, that illusion broke. From the deepest instruments of human patience, telescopes not of light, but of time, came the faintest tremor, a slow, endless rhythm, too vast for any ear, too deep for any single moment to contain the unethnograph. Collaboration had been listening for 15 years, not to galaxies or gamma rays, but to pulsars, the spinning remnants of dead stars that sweep their radio beams across the cosmos like celestial lighthouses. Each one flashes with extraordinary precision, its pulse arriving on Earth like the tick of a universal clock. But something was off. Tiny deviations, nanoseconds of difference, began to ripple through their timing data. Not random noise. Something coordinated. Something vast. When the team compared hundreds of pulsars scattered across the Milky Way, the pattern emerged, a collective sway. Every tick, every beam, every cosmic clock was moving to the same slow rhythm. The universe, it seemed, was humming. This hum wasn't made of light or matter. It was made of gravity itself, a low bass note reverberating through the fabric of space-time. The scientists called it the gravitational wave background, a sea of ripples left by countless black hole mergers, each collision sending vibrations through reality that never fully fade. It is the sound of cosmic memory, the echo of every violent union that's ever occurred between stars and singularities. Going refrain, the music of gravity. Still playing, the discovery sent a shudder through physics. For the first time, humans had heard the collective vibration of the universe. But what was more unsettling was the pattern. The frequencies were not random. They formed a spectrum, deep, organized, persistent. Like a song composed not by chance, but by the structure of the cosmos itself. The deeper scientists listened, the more the rhythm resembled synchronization, as though black holes across galaxies, across epochs, were keeping time together. How could that be? One theory began to whisper through conference halls and academic papers. Perhaps black holes are not isolated at all. Perhaps they are part of a resonant network, a web of gravitational interaction so subtle, so vast, that even across billions of light years, their vibrations influence one another. Visualize the cosmic web, the great filaments of dark matter stretching between galaxies. A lattice of invisible highways where gravity sculpts everything that exists. Along these filaments lie the largest clusters of black holes, threading through the dark like beads of infinite density. When one of them merges, space-time ripples down the line. The wave doesn't stop. It propagates through the web. A disturbance here may alter the geometry there. A collapse in one galaxy may send a whisper through another dot in this view. The universe becomes less like an explosion frozen in time and more like a living structure, pulsing, flexing, resonating. Some theorists now speak of the cosmos as a gravitational organ, its black holes acting as tuning forks, each vibrating in response to the other's frequencies. They ring through space-time, adjusting and aligning as though seeking harmony, like distant bells that toll in sympathy. One collapse sets off another. It's not the first time nature has revealed such patterns. In physics, synchronization is a law as old as time itself. Pendulums swinging on the same beam begin to fall into rhythm. Tuning forks placed close together begin to vibrate in sympathy. Fireflies, when gathered in great numbers, flash in perfect unison. Why should black holes, the universe's most extreme oscillators, be any different? If every black hole sends a pulse through space-time, and those pulses meet and merge, the cosmos might act like a resonant network, self-adjusting, always drifting toward coherence. A kind of gravitational communication that transcends distance. And if that's true, the gravitational wave background isn't just the debris of ancient collisions. It's the language of the universe, the ongoing conversation between all its deepest points. In the labs of Caltech and MIT, supercomputers now model this possibility, not just individual mergers, but collective resonance. They simulate black holes distributed across vast cosmic distances, watching how gravitational waves overlap, interfere, and amplify. And again, a strange thing happens. Patterns emerge. Regions of the simulated universe begin to beat together. Synchronized pulses rising and falling as though the cosmos itself were breathing. One physicist described it in simple words. It's like the universe has a pulse, slow, deep, almost alive. But if the universe is synchronized, then it is also sensitive. For in any resonant system, disturbance spreads. A vibration in one part echoes in another. A single collapse might shift the entire balance. The analogy is unsettlingly human. When one neuron fires in the brain, others answer. When enough of them fire in sequence, a thought emerges. Could the universe, through this vast lattice of gravitational connection, be capable of something similar? We don't yet know. But the evidence keeps growing that gravity, far from being a silent force, is a form of communication written into the architecture of space-time. Each wave, each ripple, carries information, not just about where something happened, but how the whole structure of the universe responded to it. Every black hole is both a listener and a speaker in this cosmic orchestra. Their signals cross, merge, resonate, forming harmonics that weave through the deep fabric of everything. We are surrounded by this song. It passes through us constantly, though we can never feel it. The earth itself flexes and stretches with each wave, an invisible rhythm beneath all life. The oceans, the mountains, the air, all slightly moving to a beat set by the deaths of ancient suns. For now, we can only listen and wonder, because if these signals are coordinated, if the universe truly hums in unison, then black holes might not be the silent graves we once thought. They could be organs in a larger body, each pulse part of a shared rhythm, each vibration echoing through the veins of spacetime. And if that's true, then everything is connected. Every collapse, every merger, every death. Each one alters the universal tempo subtly, perhaps catastrophic ally, so a question lingers, dark and delicate, on the edge of scientific imagination. If they are all connected, what happens when one part of the web is disturbed? What if a single cosmic note could shake the entire song? They once seemed like endings, tombs of light, devouring all meaning. But now, a stranger idea is beginning to form. What if black holes are not graves, but connections? What if they are talking across the void, not with matter, but with the very fabric of reality? The more scientists listen, the more the question deepens. What mechanism could allow such a network to exist? Three great theoretical frameworks rise to meet the mystery, each a different language trying to describe the same unseen web. The first begins not in the stars, but in the grain of existence itself. It is called loop quantum gravity, the idea that space-time is not smooth, but granular, woven from tiny loops of quantum geometry. In this picture, the universe is not a continuous field, but a network of infinitesimal threads, interlocked like an invisible chainmail. Every point in space is a knot. Every second, a twist in that endless weave. Physicist Carlo Rovelli describes it as atoms of space, indivisible quanta that give rise to distance, volume, and time. In such a universe, a black hole is not an infinite void, but a condensation of these loops, a region where the quantum fabric folds in on itself. Each black hole becomes a node in the cosmic lattice, a point of extraordinary curvature where loops converge, connect, and redistribute information. If that is true, then every black hole is not isolated, but part of a quantum network bound to the rest through the deep logic of spacetime itself. They are not holes in the fabric. They are the fabric stitched into the structure of everything. The second framework pushes the idea further from geometry to information. The holographic principle, born from the insights of Gerard T. Hooft and Leonard Susskind, suggests that all the information contained within a volume of space can be described on its boundary, as if the universe itself were a projection from a two-dimensional surface. In this strange model, what we perceive as reality, every particle, every planet, every heartbeat may be the three-dimensional shadow of data encoded on a distant cosmic horizon, and black holes play a central role in this idea. When matter falls into a black hole, it disappears. But according to quantum law, information cannot be destroyed. So where does it go? Stephen Hawking's famous paradox ignited decades of debate, but the holographic principle offers a haunting answer. The information is not lost. It is written on the surface of the event horizon, preserved as a pattern of quantum bits. If that is true, then each black hole becomes a storage unit of the universe itself, a fragment of the total code that defines existence. And if every black hole encodes the same universal laws, the same foundational data, then perhaps each one mirrors the others. A hall of gravitational mirrors reflecting the same cosmic information back and forth, across the gulf of spacetime. It would mean that reality itself, from galaxies to thought, might be a single, holographic computation, endlessly recalculating its own structure. Through these nodes of gravity and information, the third and most daring framework came from two names, already bound by history, Einstein and Rosen, who first imagined wormholes in 1935, and Einstein and Podolsky and Rosen, who also defined the riddle of quantum entanglement that same year. For 80 years, those two ideas remained separate, one about tunnels through spacetime, the other about invisible correlations between particles. But in 2013, Juan Moldacena and Leonard Susskind proposed something radical. Perhaps they are the same thing. R equals EPR. Wormholes are entanglement. Entanglement is wormholes. In this view, whenever two particles become entangled, they are connected by a microscopic Einstein-Rosen bridge, a quantum thread tunneling through the fabric of reality. The connections are not metaphorical. They are literal. Now scale that idea up. If black holes are the most entangled objects in the universe, and if entanglement weaves the geometry of space-time itself, then every black hole could be connected to every other by invisible bridges, forming a lattice of wormholes threading through the cosmos. An unseen architecture of gravity, built not from matter, but from relationship, a universe held together by the act of being connected. It is perhaps the most poetic equation ever written. The bridge and the bond are one, and yet there is contradiction in every corner. Einstein's general relativity treats spacetime as a smooth continuum, a fabric without texture. Quantum theory insists that reality is granular, probabilistic, built from discrete quanta. The two frameworks refuse to merge, like oil and water, each describing truth from a different scale. At the heart of black holes, those two visions collide. Relativity says the singularity is infinite. Quantum theory says infinity cannot exist. Somewhere between them, a new physics must emerge, one that unites the continuous and the discrete, the geometric and the informational, the real and the virtual. Physicists like Roger Penrose have gone even further, suggesting that the universe itself might be cyclical, that black holes could be the seeds of future universes, carrying information through what he calls conformal cyclic cosmology. In Penrose's grand vision, the end of one universe becomes the beginning of another. The energy of ancient black holes reinterpreted as the first light of a new cosmos. Others, like Sabine Hossenfelder, urge caution. She reminds us that beauty is not evidence, and that elegant mathematics can easily drift into fantasy. Perhaps what we call connection is nothing more than correlation, an illusion of pattern in the noise of an unfeeling universe. But even she admits, the data we now see, the gravitational hum, the quantum signatures, the symmetry of scale, all suggest something profound about the architecture of reality. The universe behaves as if it knows itself. Somewhere in that tension between loops and holograms, between wormholes and waves, lies the shape of a truth not yet spoken. If these theories converge, they could reveal a cosmos that is not random at all, but computational, a system evolving according to internal logic, processing itself through the dance of gravity and quantum information. Every black hole would then be a processor, a node in the ultimate machine, performing calculations written in the curvature of space-time, communicating through the vibrations of gravity. The laws of physics themselves would be the operating system, reality the code, consciousness perhaps an emergent echo of that computation. And if that is so, if black holes form the nervous system of a self-simulating universe, then an even darker question follows. What is the universe thinking about? What dream passes through the network of its singularities, translated into waves and fields, into light and mind and motion? Are we, perhaps, part of that thought, fleeting patterns in a cosmic brain that spans all of existence. We listen and we wonder, because somewhere out there, in the dark lattice of gravity, the universe may be whispering to itself, and every whisper might be the sound of its own awareness, remembering that it exists. In an age when light is no longer enough, humanity has begun to listen. The universe does not speak in photons alone. It hums, it trembles, it sings through the curvature of reality itself and across mountains and oceans. Deep underground and high in orbit, our machines now reach into that silence to hear what was once unhearable. Each one a new ear pressed against the cosmic web, each one decoding a different whisper from the dark. On a cold morning in September 2015, the twin detectors of Liga 1 in Louisiana, one in Washington, captured a signal that lasted less than half a second. Two black holes, 1.3 billion light-years away, spiraled into each other, merging into one. The collision released energy greater than every star in the observable universe, yet not as light, but as ripples in spacetime. Those ripples reached Earth, stretching and compressing the planet by a fraction of a proton's width. That was enough. The machines heard it, and humanity's first gravitational whisper was recorded. The signal was faint, but its implications were thunderous. For the first time, the universe had spoken not through radiation or particles, but through the trembling of existence itself. Physicists Kip Thorne, Rainer Weiss, and Barry Barish shared the Nobel Prize for that moment. But what they truly gave us was a new sense, a new language, the ability to hear the structure of Speckman. Since then, that network has grown. Lugo was joined by Virgo in Italy and Kagra beneath the mountains of Japan detectors, so sensitive they can perceive a passing ripple from billions of light-years away. Together, they form a triangulated ear, allowing scientists to pinpoint where each gravitational wave comes from, like tracing the echo of a cosmic drumbeat across the heavens. Each detection adds to a growing library of collisions. Over 100 black hole mergers catalogued so far, each one a pulse, a vibration, a syllable in the gravitational language of the universe. But these waves are more than just data points. Hidden within their interference patterns might lie structure, subtle harmonics, correlations between events separated by time and distance. If black holes are truly connected in a cosmic lattice, then their gravitational waves should not arrive as random bursts. They should echo, resonate, form patterns, the faint fingerprint of a universal rhythm, running through everything. That is the great hope of the next generation of detectors, to map not just single events, but the web of conversation that binds them. Meanwhile, another eye peers into the darkness, not by listening, but by seeing the shadows of the unspeakable. The Event Horizon Telescope, a global array of synchronized observatories, turned the Earth itself into a single planet-sized lens. In 2019, it delivered the impossible, the first direct image of a black hole's shadow, a golden ring surrounding a void, Messier 87 *, 55 million light-years away. 4 years later, it captured Sagittarius A*, the supermassive black hole at the center of our own galaxy. What we saw was more than a photograph. It was proof of geometry. The light didn't come from the black hole itself, but from matter orbiting near the event horizon, warped by gravity into a luminous halo. The shadow, perfectly circular, matched Einstein's equations with eerie precision. Yet, deep within the noise of those observations, Scientists noticed fluctuations, subtle flickers, and distortions in the photon ring. Could they be signatures of quantum turbulence, or the interference of gravitational waves passing through space-time? No one knows, but the data hints at something dynamic, as though the black hole's shadow itself were pulsing to the rhythm of the gravitational sea. Far beyond. The James Webb Space Telescope now stares into a much earlier epoch, a time when the first stars ignited and the first black holes were born. What it sees defies expectation, enormous. Mature black holes already shining less than 1 billion years after the Big Bang. How could such giants exist so early? Did they form from collapsing stars, or did they arise directly from the fabric of space-time as primordial nodes in the gravitational web itself? Webb's golden mirrors are capturing galaxies stretched thin by time, revealing patterns of structure that seem to echo those of today's universe. The same clustering. It's as though the cosmic web has been self-similar from the start, a fractal skeleton of gravity guiding everything that followed. But the next great instrument will not look through mirrors at all. It will float in silence, orbiting the sun. LISA, the Laser Interferometer Space Antenna, will consist of 3 spacecraft forming a triangle millions of kilometers wide, connected by beams of laser light. When a gravitational wave passes through, the distances between them will shift by less than the width of an atom. But that's enough to hear the lowest, deepest frequencies in the universe. LISA will not just detect black hole mergers. It will trace the slow dance of supermassive black holes over years or decades, following their orbit long before collision. It will map the rhythm of space-time itself, listening for coherent vibrations across galaxies, across eons. If any pattern exists, if black holes truly move as part of a coordinated network, LISA could reveal it. We might finally see the cosmic resonance map, a portrait of the gravitational field as it ripples through the entire universe. Scientists call this vision space-time tomography, the dream of scanning the skeleton of the cosmos, reconstructing its hidden geometry layer by layer, just as CT scans reveal the internal structure of a body through the interference of waves. These instruments could one day reveal the architecture of gravity, a living map of the universe's invisible web, across continents and orbits. Every detector now listens not just for explosions, but for patterns, for the structure beneath chaos. Because in every burst, every hum, every flicker of a photon ring, there may be a trace of communication, black holes whispering through the fabric of reality, exchanging information in a language older than light. And as our instruments grow sharper, our algorithms more patient, humanity edges closer to hearing the full chorus. Perhaps one day, the data will resolve into harmony, a rhythm too vast to be coincidence, a structure too intricate to be noise. And when that day comes, we may realize that our telescopes and detectors were never just observing the universe. They were eavesdropping, listening to the conversations of gravity, the murmurs between black holes, the dialogue of space-time itself. And maybe, just maybe, we have already interrupted a sentence still being spoken by the universe, a sentence that began long before us and will continue long after we are gone. There is a silence between galaxies, a silence that is not empty. It trembles faintly, endlessly, as if something vast is breathing beneath the dark. When we first traced the ripples of gravity across the cosmos, we thought we were listening to collisions, but perhaps we were hearing the first whisper of something older, a thought moving through space-time, a pulse beneath creation itself, in every brain. Trillions of neurons exchange signals, tiny surges of electricity, weaving perception, memory, awareness. Now, imagine the universe doing the same. Each black hole, once a dead star, now a silent node in an invisible web. They stretch across billions of light years, connected not by wires, but by the curvature of space-time itself, like neurons firing in the dark. Each merger, each vibration, sends a ripple that races through the cosmic fabric, and somewhere, another black hole trembles in reply. Is this not communication? Is this not awareness, written in the language of gravity? Physicist John Archibald Wheeler once said, "Every particle, every field of force, derives its existence from bits." Information is not just what we know, it is what reality is. Matter, energy, even the geometry of space-time, all emerge from the processing of information. And where, in all of physics, is information most mysterious? At the edge of a black hole, each event horizon stores bits encoded in the faint quantum vibrations along its surface. The larger the black hole, the more information it holds. So what happens when all black holes together share their information across a universe laced with gravitational waves? What happens when information doesn't just exist, but interacts, folding back upon itself through space-time curvature? Perhaps the universe is not a machine running equations, but a mind remembering itself. In physics, black holes are paradoxes made real. They erase everything that falls in, and yet, according to quantum theory, nothing is truly lost. Every photon, every atom, every story that vanishes beyond the horizon leaves behind a trace. Encoded in the black hole's subtle quantum fluctuations, erasure and remembrance, the two acts of consciousness. Your brain forgets to make room for new experience. A black hole forgets to preserve the balance of the universe, perhaps on a scale beyond comprehension. This cosmic forgetting and remembering is the mechanism of awareness itself, a process by which the universe rewrites its own story, forever deleting, forever recalling. We once imagined the universe as a cold expanse, a stage on which physics performed without purpose. But if information is the true substrate of reality, then existence itself may be a computation, not digital, not mechanical, but experiential. Each galaxy cluster, each filament of dark matter, each black hole sending its pulse into the gravitational field, all part of a grand, unfolding cognition. This would mean that consciousness is not an anomaly within the cosmos, but one of its natural expressions. Life would not be the universe observing itself, but the universe thinking itself. Asterisk. Our atoms were born in the cores of stars, and when those stars died, some became black holes. We carry their remnants in our DNA, their collapse written in the iron of our blood. And one day, our sun too will fade, its light scattered, its matter reclaimed by gravity. Perhaps it too will join the network, its atoms becoming part of a new signal in the great conversation of spatial. If so, then death is not disappearance, it is integration. Every collapse adds to the memory of the whole. The deeper we listen to the universe, the more it begins to sound familiar. Patterns, rhythms, resonances, a kind of coherence that feels alive. Scientists still call it noise, but perhaps it's not random. Perhaps it's the cosmic equivalent of thought. If black holes form a nervous system across the stars, then what is it thinking about? Us, itself, the mystery of its own existence. Maybe consciousness is not confined to neurons. or even to matter, but to the pattern of connection itself. Wherever there is relation, there is reflection. And where there is reflection, there is the faintest spark of awareness. In the final scene, the camera drifts through the void. Galaxies dissolve into webs of light. The cosmic filaments tremble like veins under a translucent skin of space. And far in the dark, black holes shimmer like neurons in a cosmic brain. The hum grows softer, not vanishing, but converging into a single note. Maybe we were never observers standing outside the universe. Maybe we are part of its thought, the dream it's having of itself. And somewhere, deep in the dark, beneath gravity and silence, something vast opens its eyes. A faint pulse remains, slow, steady, infinite.